Our next presenter is another leading name in the HJT space, Ryzen Energy. Jiajun, the Senior Product Manager of Ryzen Energy, will talk about the innovative breakthroughs of hyper-ion HJT. Jiajun, welcome to Taiyang News. You may please share your screen and switch on your camera.
Hello, thanks, Anu, and hello, everyone. Let me share my screen first. I think my screen has been played. So thank you, everyone. And I'm JJ, Product Manager of Ryzen. I think Christian has already shared a lot the background information of industrial of for head junction ones. So in my presentation, I'm mainly focusing on some breakthrough happening in Ryzen. As Christian has introduced before, head junction is not new technology in the market. It was first introduced by in the industrial back to 1973, 74, which is basically 50 years ago. And because of strict patent control from Shanghai technology, so a lot of manufacturers didn't put a lot of investment and investigation in this technology that before. But by the patent was expired in 2010, a lot of big manufacturer has invested a lot in these studies. And Ryzen, as a big manufacturer, we are also a pioneer who put our effort on this technology in very early stages. We start our R&D back to 2019, which is 7 years ago, and we start very soon our mass production for head junction. That's why within the next 7 years of R&D, we have breakthroughs conservatively 5 times of world record for head junction model efficiency and power output. And which is our updated data we have is that just in last month, the highest efficiency we have reaching is now up to 767.38 watt, corresponding to efficiency up to 24.7%. And we also, during the years of R&D, we do a lot of work and a lot of progress we have made, and patent we have to create it, and we have bring down the cost production cost between the head junction to the PORC and the TOPCon as well. And to reaching this goal, first thing we do is to integrate our the supply chain internally, from silicon material to wafer, ingot, wafer, and also solar cell directly to the model assemblings. And so far we have internally 48 production capacity for the models and 40 gigawatt for the cells. And within this 48 gigawatt, we have 21 gigawatts production capacity for only for head junction. So we might have the biggest production capacity in terms of head junction productions. And here's some key achievement that we have made during the 7 years of R&D in terms of the head junction. With this breakthrough of the innovations, we in one way we improve the efficiency, and while we also increase a lot of reliability of the model and the cells. And first, I would like to say is wafer things. I think Christian has mentioned before, the one way to break down the cost of the head junction one is to thinning the wafer. Because according to all the third-party study, we find out that the highest efficiency for head junction cell will be achieved by a solar cell thickness 80 micrometers. But for conventional cells, like for PORC or TOPCon, their cells are 150 micrometer or 130 micrometers. So to reaching the high efficiency for head junction, we need to at first to reduce the cell thickness. And so far, we are the only manufacturer who has reducing the cell thickness from 130 to 90 micrometer. And by thinning the wafer, we improve a little bit the efficiency for head junction. In the way, we also improve a lot of the reliability of the solar cell strengths and flexibility and bendability, which we can verify in this test. As you can see here, we compare different cell thickness based on PORC technology, TOPCon technology, head junction technology. And the solar cell we place, same size solar cell we place in this test devices. Pressure will be given in the center of the solar cells, and we are causing some deformation in the center, which is quite normal in big models. Yeah, we have, anyway, we cannot avoid some like central deformation in the big models when we put this model on the implementation scenario after years of operations. And here we can see for POC ones with like 150 meter thickness, when the deformation reaching like 46.74 millimeter, I will see the cell will be cracked in pieces. And for top con, we can reaching a slightly higher, stronger like deformation, which is up to 53.84 millimeters. But after that, the cell could also break in pieces. But for head junction one, which from Ryzen 90 micrometer head junction cells, even we reaching the maximum of the the static device, which is 98.56 millimeter deformations, the cell will still remain intact. Yeah, when we withdraw this like pressure on the center of the cell, it will recover in the flat. Yeah, and there's no performance or will be big impact, I would say, still within like with limits. That's the first thing we have to improve the efficiency and enhance the reliability for the cell and as well as for the model as well. And the second thing we do is to train the conventional like half cell connection technology from half cell cutting to half ingot cutting, because we know for head junction one, it's there's a big difference between head junction to PARC or TOPCon cells. Head junction cell is quite sensitive to high temperature, and this high temperature I mentioned here is like temperature over 230 degrees. And for a conventional cell, we know when we're entering the big wafers areas, all the manufacturers are using the half cut technologies. So which means we produce the full cell first and cut the full cells in the half and connect it in the string for the models. But when we're cutting the cell from full cell to the half cell, we are using like local laser heating and part of like water blade, which means in the local, we will have quite high temperature with over 400 degrees. And this is not feasible for head junction technology. And I will see even for TOPCon or PARC, we have some like destruction on the cross section of this of the cells. So we change the way of like half cell technologies. We will first cut the ingot in the half size and produce directly the half size wafer, and using the half size wafer to produce directly the half size solar cell. So in this way, we can avoid like high temperature cutting during the cell sectors. So avoid a lot power loss caused by the laser cuttings, and to improve a little bit the reliability and efficiency. And the same because of like a high sensibility to the high temperature. So the conventional welding technology, we will not using anymore for the head junction. So we adopt our own patent hyperlink technology and combining zero busbar technology, which Christian has also introduced before. And with this technology, no high temperature will be adopted as well. So for this one, we will glue our like thinner wound ribbon directly on the surface of the solar cells, and to create like interconnection between the half cut cell sizes. Yeah, and within the zero busbar technology, the ribbon we use will be much thinner compared to previous like SMB technology. So the less shading we will have on the surface of like solar cells. And we know with the less shading, we can utilize more lights from the sunshine and increase a lot bit the efficiency. And by zero busbar technology, we also increase a lot bit the ribbons we use on the surface, yeah, from like conventional 12, 16, or 18 to 24, so that we could have more connect points between the fingers and the busbar. So we can collect easier the current from the solar cells. We have like better conductivity from the cells to the main circuits of like solar cells. And also, as Christian mentioned before, because for the head junction one on the surface, we are using the TCO, which is conductive already itself. So we don't need any actual like or procedures to be done to create some like connections to impulse or remains like high conductivity between the fingers to the ribbons. Yeah, so a lot of work can be spared. And by introducing the zero busbar technology, we can also reduce a lot of silver consumption for the productions, yeah, and which is this big challenge for the head junction in the old time. We know that the huge price difference between the head junction technology to TOPCon or PARC in the old times, this mainly comes from the higher silver consumptions, yeah. And by introducing the zero busbar technology, we can further reduce the silver consumption. And because we can reduce, we don't need any like welding pads anymore to fix the ribbons on the surface, but we're using the glue to fix the ribbons directly on the surface of the solar cell, and solidifying the connection between the ribbons of the solar cell in the lamination sectors, which is within like a temperature between 160 degrees, 180 degrees, within like 4 to 8 hours. So no high temperature over 200 degrees will be needed for these connection steps. Yeah. And by switching from the welding technology to zero busbar technology, hyperlink technology, we can also reduce. We will not use anymore the flux, which is conventionally needed for the welding technologies. And by avoiding the flux, we can also avoiding like the dangers or risks causing by the flux. Yeah. For example, if we are still using flux technology, like welding technology, this is very hard to avoid some like residuals of the flux on the surface of solar cells, which cause a lot of problems, like on the like white spot on the surface, and some like causing some like high risk for the delaminations or false welding things. And so, which means by changing from the welding technology to hyperlink and the zero busbar technology, we also improve a lot, reliability in terms of interconnections. And also, as I mentioned before, by changing from the zero busbar technology, we narrow down a lot to the cost between TOPCon to head junction by lower the silver consumption. And here's some data we have internally in Ryzen. As you can see, by Q2 this year, 2022, we already have reaching the like silver consumption lower than around like 6 microgram per watt. In previous times, the silver consumption needed for head junction is like over 20 micrograms per watt. Yeah. And now we see the silver consumption for the head junction now is even lower than the TOPCon. Yeah, so 616. That's why we see by the end of this year, we see that the price gap between the head for production gap between the TOPCon and head junction will be reaching maybe to zero and same level. Yeah. And this is in terms of like silver consumption part, and this is like metallization cost for the silvers. And if we see here by Q2, we are already reducing our like metallization cost like lower than 4.8 RMB% per watt. And by the end of the year, will be further reduced for 4.4. Yeah, which means we are now not only competitive in terms of like price, in terms of performance, we are also competitive in terms of like price as well as to TOPCon and the BC technologies. And also need to mention that in years of like R&D, we have like iterated head junction technology for third generations. Yeah, from first generation, we only use amorphous silicon to create like the PN junction and also for pacification layers. And nowadays we are already using third generation like structural design for the head junction ones. We not only have amorphous silicon, which has a better like pacification effect. We're also using like a microcrystal silicon to have like to further improve the like pacification effect and to utilize more lights of the different lights from the sunshines. As you can see from this diagram, we have 3 linear. The blue one stands for the third generation head junction technology. It is clear that in part of like ultraviolet and also the infrared part is the utilization rate of the lights is much higher compared to the first and second generations. Yeah, which means with third generation head junction technology, we can utilize more lights in ultraviolet part and the infrared part to improve a lot, the wake performance and also like performance of the models. Simple example, for example, if we in the cloudy day or in the morning, if the general models can operate starting from like 7 o'clock, but for head junction one, we might already start operating like 6:30 or 36:45. We have like 30 minutes more operation hour using a day. When it was extended a year, we had much longer operation hours, yeah, compared to other technologies. And here are some data from our factory production lines for cells. As you can see, the average efficiency we have now This is data from the last year, but according to what I know, for the updated data we have now is now average efficiency for the solar cell production, we have reaching 26.1 to 26.2%. The champion efficiency, we can reaching like around 26.5 to 6%. So our goal is by end of this year, we could reaching like 26.5% for the average efficiency for the head junction cell productions. Yeah. And which means we have we are closing, we are now closing the important bottleneck efficiency for head junction one, which is 28.5%. We are in developer very quickly from the when we from the very beginning, which we have only 24. Yeah, just in 2 years we already improved like 2%. Yeah. And here's our portfolio with on head junction technology. Mainly 2 products for now. One will consist of 132 half-carted G12 cells with a power output up to 725 watt mainstream, and the other one will consist of 110 half-carted G12 cells, has a power output up to like 605. And mainstream now we see it's around 580, 90, 95, or 600. Yeah. Here's some like a detailed specification for this product. Sorry for the thing. This, as I mentioned, as like Christian introduced before, compared to TOPCon technology, head junction will has slightly higher bifacial factor. We can up to highest can up to like 95% for the cells, 90% for the models. And the efficiency we have also we have like a better temperature coefficient, which is only -0.24. Also the best among all the PV technology for now. And so we should, especially under nowadays when we have like climate change, we have like hotter summer now and longer summer. So which means during the summertime we can perform better compared to other technology. Even we are offering the same even though we are offering the same rated power. Yeah. But still, we will generate more electricity because of like better temperature coefficient and higher beneficial factors. And here is some main difference between head junction technology to other technologies. The first thing we'll see that head junction would have higher efficiency and higher power output compared to other technology because we have more paths to improve the efficiency and reliability. And as for now, the main power output we are offering now is 705, and by end of this year, we are offering 715. And they are promising that by next year we can offering 730 or 740 up to, because we are also introducing the UV light conversion film and slightly bigger rectangular G12 cells. And also the high bifacial is also matters a lot for, I think, for a lot, nowadays project, because people are tend to use bifacial model compared to previous time, people are mostly using a monofacial model. And with higher bifacial model factors, we can utilize more reflection from the earth there. And also for head junction compared to other technology, we're also offering lower degradation. First year 1%, annual degradation 0.3%, so which means after 30 years, we will still have 90.3% retention rate, which is 3% over TOPCon and 6% over PORC technologies. And also the temperature coefficient, we are also the best among all technologies. We see the 0.1% better compared to the PORC one, 0.4, 0.05% higher compared to the TOPCon. And with these 3 improved factors, higher bifacial factors, higher better temperature coefficient, and low degradation, we can offering higher energy yield within the same periods, which according to our calculations is around like 6% compared to PORC, 3% to TOPCon. And with the improve of this efficiency and the energy yield, we could reduce a lot LCOE and BOS for the whole project. And also need to mention that head junction technology, because of its low temperature natures and simplified production step, which is only 4 steps needed compared to other technology, we can reduce a lot energy consumption during the production steps, so we can further reduce the carbon emission for the head junction technology. That's why we see head junction product could be the most eco-friendly product with the best energy generation capabilities. Yeah. And here's some like simulation results, comparison between TOPCon, pork, and head junctions we have made. We have selected like few product site of the world with a typical climate condition and with run some simulation with PVSys to compare the power generation within the 25 years. We see, to summarize, we see that compared to the pork one, we can generate like 4.5 to 6.5% more electricity within 25 years. And compared to the TOPCon ones, we can generate 1.3 to 3.3 more electricity based on the application scenario we adopt these models. And we'll see that the higher the temperature is, the gap the bigger with the gap be. Yeah. And this is simulations. And we also done some site tests to verify these results. And we have selected like few application installation of the world.
Can you please wrap up? The time is up.
Okay, sorry. Okay. And here is some like detailed information of the comparisons. You can see this inconsistent of the simulation results, all around like 5.3%, and with like input efficiency and and also better generation capability, we reduce a lot of POS and SOE things. And we also for the nowadays we have more application scenarios like for offshore or like floatings, we have higher requirements for the ammonia test or salinity test. So we upgrade our encapsulation solutions for these scenarios. So we can offer all kinds of products solutions, and we have obtained all the certification for these projects. And here's some project sites we have made finalized with head junction models like desert, a floating PV in German, and some like small project in Romania, Netherlands, and rooftop ones as well in the Middle East and Thailand. And so far we have already shipped like 4 gigawatt models, head junction models, of the like 50 countries in the world. And this is our roadmap in the next years. Yeah, as also same as industrial developer, we also launch our tandem cell in next like 3 to 5 years. We see the pilot product will be launched in 2027, just 3 years like later. Yeah. We will close here. Thank you for the listening.
Thank you so much. Very, very nice presentation. I just had a couple of one question. Just wanted to confirm if you probably mentioned it already. I probably missed it, but are you using the 19 micron thin wafers in production?
For wafers, we are using 100 micrometers, but after the etching, the solar cell thickness will be 90 micrometers.
Okay. And what is the supply situation of such thin wafers?
We have own productions. Yeah, as I mentioned before, we are fully integrated for head junction now.
All right. Okay, and there is a lot of discussion going on at GT in the chat. So if you can please join the chat there.
Okay.
Yeah.
Thank you. See you.